Hey, everybody. Welcome to this special LinkedIn Live. It is National Cloud Database Day. Actually, National Cloud Database Day is officially, and it is an official holiday, it's on June 1st, which is Saturday. So we're celebrating a little bit early today, May 30th. We have a lot of activity going on in our office at Couchbase today to celebrate. And we wanted to bring some of the celebration to you. Today, we're going to talk about cloud to edge Gen AI and vector search with Couchbase. So we made a little kind of joke here about our being in our AI era of our database era, continuously trying to keep up with the top trends and things that the customers need to build excellent applications, adaptable applications. So today I bring to you Shivay Lamba. He is a developer evangelist at Couchbase, and also Mark Gamble, Director of Product and Marketing Solutions. And I'm going to kick it off to Mark to get started. Thanks for being here, you guys.
Awesome. Great. Thanks, Suzanne. I'm going to go ahead and into our sharing here. Mark here again. I'm excited to be here today to talk about Couchbase. Of course, this is the database that offers AI-powered development for AI-powered applications. And we'll be covering in today's episode, cloud edge, AI, and vector search. And there's no better qualified person to join the discussion with me than my good friend and colleague, Shivay Lamba. Shivay, thanks for being here with me today.
Hey, thank you so much, Mark, and always great to share the stage with you. And super excited to interact with the audience today on my favorite topic around Gen AI. We are living truly in a revolutionary space where we're seeing so many different kind of AI applications coming up, and it's just great to be at that forefront and empowering developers to use AI applications with the help of Couchbase as well. So super excited for today's webinar.
Well put, and so am I. And as you mentioned, we're celebrating National Cloud Database Day. So coming up on June 1st, there's only 2 shopping days left. So get out there. And we're celebrating that great day because, again, we'll be talking about also my favorite topic, the Couchbase Cloud Database. So a little bit on our agenda. We're going to first talk about this notion of AI-driven adaptive applications. You know, Suzanne mentioned it, Shivay mentioned it. What does it actually mean? And then we'll talk about what Couchbase is and how it sort of fits the requirements for an adaptive application. And then we'll get into Couchbase's AI strategy and cover off on a few of the AI capabilities that we bring to the table, including a short live demo of Capella IQ. And then the meat of the matter, AI-driven apps at the edge with mobile vector search. Shivay built a really compelling reference application that really brings this to life. So we're going to take a look at that. Be sure to stick around for the whole thing. We're going to start by examining, again, the concept of an AI-driven adaptive application. And, you know, these points really encapsulate the end goal for many of our customers. They might not call them adaptive apps. We've just chosen that as a descriptive term. But whatever name they actually assume, these apps need to be adapt themselves for individual users, essentially, because that's what keeps people using these applications. And by adaptive, we mean apps that are hyper-personal, right? They feel like interacting with a human, with a friend or trusted advisor. They're in context and they present relevant options that make sense. They're driven by trustworthy data for accuracy, and they operate in real time and work everywhere with or without internet. And Gen AI is really propelling expectations for this type of experience. You know, essentially apps, everyone is clamoring to build these type of applications and this type of experience. And arguably, one of the most critical pieces of this puzzle of achieving this is data. You know, how and where you process it can have a huge impact, both positive or negative, on the user's experience with any given application. And AI is already redefining our experiences with these applications, you know, these types of apps. More and more, emulate interacting with a real person. They present offers and recommendations that are, sometimes eerily accurate. Have you ever been recommended to connect with that old colleague that you were just thinking about yesterday? AI is how they do that. These apps are becoming, essential to do smart things in real time, like save 15 minutes on your current route to the office. And when done right, they can really blur the lines between the digital and physical world. Sounds dramatic, but it's all true. And use cases can take many forms. LLMs are really great at generating content. So it can be used to do things like, summarize massive amounts of input. Here we see a summarization of reviews for a product as an example. Advanced analytics and machine learning is really great at classification and anomaly detection, among other things. And so perfectly suited for fraud detection and risk analysis type applications. And search techniques use AI to make a connection with users, presenting offers and making recommendations that are timely and in context. And conversational AI is becoming ubiquitous in chatbots and helper apps that nearly every website and app offers these days. So, how and why are we qualified to assert these observations? It's because our customers are evolving to adaptive applications built on Couchbase. So if we look at this from the bottom, if you use LinkedIn, you're using Couchbase. They use us to power their user profiles and their login. Carnival Cruises provides a hyper-personalized experience for passengers with Couchbase running on vessels at sea and powering their Ocean Medallion IoT experience for their passengers. Domino's makes real-time decisions on campaign tactics to capitalize on changing sales trends as they occur. Emirates provides a luxury experience for passengers at 37,000 feet using Couchbase-powered apps that don't rely on the internet. And Swarm Engineering provides a predictive AI platform to optimize supply chains using next-gen cognitive computing. And all of these are examples of different evolutions of adaptive app principles, and all powered by Couchbase. So in looking ahead, we think AI will, of course, drive a transformational impact for businesses who are going to reimagine existing applications as well as create net new ones. But when we look ahead, this also reveals some architectural issues, mainly that AI prompts require diverse data, and that data needs to be operational as well as calculated. Also, architectural complexity is the enemy of AI, and the richest data for AI is created and consumed at the edge. These are core challenges, but they also play to our core capabilities. JSON is AI's data format, right? It handles diverse semi and non-structured data like a champ. And the most common use of Couchbase is for account profiles, which can be enhanced with metadata about the individual, allowing AI to engage on that more personal level. And on analytics and calculated data, classifications and recommendations, these kinds of things are just as important as the raw source data, and so should be part of the AI data ecosystem. And on complexity, right, you need a single source to feed and train your models. Don't throw data from a multitude of sources at AI and hope for the best. That's the best way to get bad results and hallucinations. So the multi-model single pool of data is really the way to go. And I mentioned it before, the crux of today's presentation is AI at the edge, because data that drives AI and user engagement is created and consumed at the edge on mobile devices and IoT devices. So having the ability to accommodate data and AI processing at the edge is really key. All right, now let's get into a bit of what Couchbase is. So I'll try to describe it in a nutshell. It's really around this multi-purpose database platform notion. So we're a cloud native NoSQL database used to power gigantic applications like those at LinkedIn that I mentioned, also Tesco, Comcast, Amadeus, United Airlines. These are big enterprise customers who use us to power their critical applications. And I mentioned Couchbase is multi-purpose, and this means it's a a combination of database capabilities. First, it's the processing of key value information in memory for hyperfast responsiveness. And second, it's the distributed storage of JSON document-based data for scale, resilience, and development flexibility. And on top of this, we add more, purposes, making it multi-purpose. So support for vector search, support for full text search, support for eventing, for columnar analytics, container support, mobile sync. These are all data access patterns that customers no longer have to bolt on from a bunch of different technologies to power their applications. They get it all from one platform with Couchbase. And Couchbase supports relational constructs like SQL queries and ACID transactions. And these are things that are not typically found with document databases. So developers can leverage their existing SQL skills. And when we look at the deployment layer here in the bottom, customers can use Capella. This is our hosted and managed database as a service. Or they can choose to manage their own Couchbase deployments in the cloud or on-prem. And this represents essentially Couchbase in a nutshell. So Couchbase Capella is, again, our database as a service hosted in AWS, Azure, and GCP. And it provides a fully managed Couchbase environment for powering applications. And being a managed cloud service takes onus off of the customer to install and configure and maintain their own environments. And this saves you time and money and reduces risk. And Capella also includes mobile support via app services. And these are fully managed services for sync, authentication, and access control for mobile and IoT apps. And app services includes the embedded database and built-in cloud-to-edge sync. So it's ideally suited for mobile apps where the internet can be spotty and number of clients can be in hundreds of millions of devices. So in fact, on that last point, we support edge architectures and mobile and IoT applications with Couchbase Mobile, which is that combination I mentioned. And the product stack is made of these three foundational components. Capella, which I just talked about, fully managed cloud NoSQL database as a service, and app services, fully managed back-end services for sync, authentication, and access control, and then Couchbase Lite. And this is the embedded NoSQL database for mobile and IoT applications. And I also want to talk about Capella columnar services. This is a soon-to-be released analytics feature of Capella. It's a columnar data store for running analytics queries against a variety of operational sources without the need to move data into a separate repository for analysis. No ETL and all the headaches that go with it. And sources go beyond just Couchbase databases. You can leverage Kafka to connect to any source, including relational, and even combine it in an overall analysis for deep analytics within columnar. And it's great for real-time operational analytics. It can be used also as a part of a data pipeline for machine learning training iterations. And it also brings the ability to leverage fully trained machine learning models via a user-defined functions feature. And this is the ability to call trained Python machine learning models right from the database using SQL. That is to feed a given set of data to the model, perhaps to classify a customer, for example, and let the model run and then incorporate the results, those classifications, back into the query response and pass it back to the application. And it's built right into our database as a service, so there's no integration required to achieve this kind of analysis. All right, so we've got a little background on what Couchbase is. Now let's talk a little bit about our AI strategy and the emerging sort of phenomena of Gen AI. Gen AI has been around actually for quite some time, but now it's become more powerful than ever and freely available to anyone. And this has led to a seismic shift in how apps are developed and consumed. What's really clear is the AI hype is warranted, and we're really just scratching the surface of the possible innovations that AI can enable. It already has, but what about the future? And the race is on towards that future, towards the next big advancement. And the first step will be to enhance existing applications. right? With all of these powerful models now being released, the hype cycle is high right now. And then the next step will be to introduce completely new applications, taking advantage of these advances. But in both cases, AI models will need to be running close to the operational applications to maximize performance and efficiency. And this is going to trigger additional app changes, including platform shifts, to the cloud. It will just accelerate that. And relational sort of polyglot designs where there are bespoke separate technologies that make up an app ecosystem. These are going to be replaced by multi-model designs meant to facilitate artificial intelligence. And it's going to be a big universal problem for applications. The opportunity is massive, and it's going to take some time for everything to settle and really clear approaches to emerge. That this is sort of our opportunity, right? Couchbase is uniquely poised to pave the way for these emerging applications because we're architected to meet those challenges that developers face when trying to produce adaptive apps. We're JSON, AI's data format. We're edge native. We process data and AI where it happens. We're multi-purpose. No more hodgepodge of disparate, loosely integrated databases and all of the complexity that goes with that. And our stack includes co-located analytics for the real-time operational data critical for real-time decisions. So these facts and observations have informed our AI strategy. First, we want to accelerate developer productivity. And we want to help your software developers make the best use of their time and get quality products to market as quickly as possible. And next, we want to provide a database platform that can help optimize AI processing. And then we want customers to deliver AI-driven apps anywhere, including the edge and on mobile and IoT devices. And lastly, we recognize great symbiosis with partners that help complete the AI ecosystem for our customers by leveraging the best technologies combined for any given solution in the end. All right, so now let's talk a little bit about one of the ways where we're delivering on that developer productivity strategy. So Capella IQ is our AI-based development assistant, and it's built into Capella. And it's great for helping new developers who are new to Couchbase adopt a NoSQL database. But it's also great for speeding up kind of the tedious tasks for seasoned Couchbase developers. So with a prompt, you can create scopes, you can create collections, you can create sample data to work with. You can use IQ to work with data, feeding plain language prompts that it uses to write SQL queries. And yes, again, I said SQL, right? This is not typically found in a document database, but it's the native query language built into Capella. If that wasn't easy enough, IQ makes it even easier. And results can even be visualized on the fly. And IQ is also built into the Couchbase plugin for JetBrains and VS Code, where developers can use it directly within their coding environment. It generates queries and SDK code to connect to Capella and makes it really easy to work with Capella right from the IDE. So at this point, I'd like to get into a bit of a live demonstration. And this is live television, folks. So I'm going to go straight out to Capella, and we're going to run a bit of a demo on IQ. So in this particular case, I've now gone into Capella, and we're in the query workbench. This is where you can actually work with queries, get a direct browser-based access to the database itself. And of course, we have access to IQ. This is the AI-based coding assistant. And in this case, I'm assuming the role of a brand new developer with Couchbase. Maybe I know some relational constructs, but not much about NoSQL. Thankfully, IQ's there to help me. And I have nothing in the way of data yet, just my IQ empty bucket, just sort of an empty database. And what I want to do first is create some structure. Suppose I'm building an app for keeping inventory for a wine shop. So first I'll ask IQ to create me a scope named wine shop. And a scope is analogous to a schema in a relational database. So here we see wine shop, that's in place. Very nice. I'll set that context. And now let's create some internal structure for that scope. I'm going to create a collection in wines in the scope wine shop. So collection is analogous to a table. So IQ takes that input and creates that. I'll go ahead and just run it. And now we see sort of my sample data working area. My database structure is already nicely formed here, wine shop with a collection for wines. So now let's actually create some data for it so that I can actually start to work with it. And I don't have to put in my own data and deal with any sensitive data issues of any kind. I can actually ask IQ to create me very specific sample data. And I didn't just want wine 1, wine 2, brand 1, brand 2. I want realistic wine names and realistic brand names, prices, and inventory. And IQ goes ahead and accommodates. It's writing all of this beautiful sample data so that I can get started understanding how to work with Couchbase immediately. So I'll go ahead and run this. And it will now insert all of that sample data, all of those documents directly into the data structure that we set up. So there it is. And in fact, if we go and look at the documents view, here we can see tons of beautiful wine data. If you couldn't tell, wine's another favorite topic of mine. So we have now been able to create that structure. Let's go ahead and actually start to work with it. I'm going to ask IQ to create me a query to show all wines from Mondavi. And again, it's just standard ANSI SQL here that we're writing, even though it's JSON-based data. So I'll run that. And the query returns a result. There's only one result. We just have a little bit of sample data. And I noticed that it took about 3 milliseconds. Well, we all know that at scale, milliseconds count. Every sub-millisecond is precious. So we want to make sure that our apps, especially when they're running at scale with tons of data, go as fast as possible. So luckily, I can speed even this fast query up even faster. IQ has detected that I can make it faster by building an index. So I'll go ahead and build that on the fly. Thank you, IQ, for that. And let's run it one more time. And when we do, we've shaved off, again, more precious milliseconds. We've made it even faster. So we're making some great progress here. Let's go ahead now and ask for another query, this time in aggregation. I'd like to understand the inventory count of each wine. But instead of running it and seeing the results, I'm going to go ahead and visualize that. So let's go straight into a chart. So there we have it. I've been just asking free-form plain text questions of IQ. It's interacting with the database on my behalf, writing those queries, and I'm wildly productive right out of the gate here with Couchbase Capella. So at the end of the day, it's the application that will be interacting with the data, of course. So what I'd like to do is get some starter code that I can use to plug this right into my Node.js application. So any SDK that you use, you just declare it when you're actually signing up for Capella. And then at any time, you just simply click that button and you'll get that code generated on the fly. And I can simply cut, copy, and paste it directly into my IDE. So that was our quick down and dirty look at Capella IQ. So it was hopefully very clear the benefits, the tremendous benefits that this AI-based assistant bring to the table. By augmenting your development process with AI, you improve developer productivity, you increase accuracy, and you save precious time, and you get those products to market faster. So now let's go into enabling AI-driven apps anywhere, including the edge. So we talked about vector search as a feature built in. Vector search is a very, very powerful feature. Built, again, right into that multi-purpose database, Couchbase. And it leverages AI to capture the meaning and context of unstructured data. And this could include, of course, textual data, but also, images and audio. And it takes this media and transforms it into a numeric representation called vectors. And the models can then, the AI models can then compare the vectors for a given input against vectors that represent other data, and thus find the nearest matching items based on their semantic meaning. So Shivay, I'd like to ask if you have any additional thoughts around the power of vector search and the importance of vector search.
Yeah, absolutely. So I think like the most important aspect of just understanding what vector search is, as you very rightly mentioned, that it's the idea is that you are taking any sort of an object and just converting them into bunch of these numerical values, and these numerical values are representing the semantic meaning of the actual real life features. So whether you have a bunch of flowers which will have characteristics like their color, what is the length of their sepal or their petal, or like let's take a more relevant example of something like the French Open. So you might have images containing images of the tennis balls and rackets, or you could have the images of the actual tennis court itself. But all of them, when converted into these high dimensional vectors, are representing the semantic meaning. And what we're really just doing is that at the technology level at Couchbase, we're able to store these embeddings directly inside of that same JSON storage without having to make any sort of other adjustments or the capabilities. So I think like Couchbase really stands out as a true all-purpose database where you can still store your typical key value based store data, but you can also just very easily now add on your embeddings as well without having to necessarily make any further changes to your entire development ecosystem. So I think like the method of being able to insert those Couchbase vectors or these embeddings that you're generating using any sort of an AI model can very easily fit in into the vector search. And then of course when you're actually doing a query, and this will something that we'll also see in our demo as well, that's planned out later in the stream, that it's super easy to also then include the actual vector search inside of that SQL++ query that you're about to write. So I think like as a developer experience, when you're introducing any new technology, Couchbase does it in a very easy to understand and easy to implement fashion, especially when it comes to like vector search use cases. And like the demonstration that we'll also be showing you is again using very simple to understand concept of how do you generate the embeddings, how do you then store them inside of Couchbase, and then leverage the vector search inside of the SQL++. So yeah, I hope with today's demo as well, people will understand how easy it is actually to be able to do vector search with the help of Couchbase.
Yeah, well put. And so important to provide kind of the essentials for an adaptive app, and being able to provide responses and address the user in context, right, with information that matters to them. And vector search is a great way of doing this. And fantastic that also Couchbase supports it along with all of the other data access patterns. So again, keeping our customers from having to knit together disparate technologies. Just do it with a single platform. So vector search is also great at providing search matches in context. We talked about that, but realistically, it can't answer all questions by itself. Consider this seemingly basic search prompt. Find casual and fun shoes that match the color of my car between $100 and $200 with good reviews in stock right now near me. This single question actually requires multiple search techniques to answer accurately. Matching a color from an image, that's a great use for vector search, just as Shivay described. But casual and fun might be best answered using text-based search. And the prices, ratings, and inventory criteria are classic, where conditions and SQL queries, while the near me is answered using geospatial search. So the bottom line is vector search is powerful, but even more so when you combine it with other search techniques and call it using a single standard SQL query. Very, very powerful capabilities, as Shivay mentioned. And vector search can also be used for retrieval augmented generation, or RAG. And this is the ability to feed vectors as extra context for LLM prompts. and that enables the models to answer more accurately. For example, a generic LLM can only answer prompts based on and that apply to its original training data. So it wouldn't know about anything past the end of that training, and it wouldn't know anything that wasn't in the original corpus of training data. So RAG essentially teaches the LLM what it doesn't know on the fly using vector embedded data, and that allows it to provide more accurate feedback. So Couchbase supports AI from cloud to edge. On the server side of the architecture, the Capella DBaaS offers the columnar service, which has real-time analytics and ML capabilities that I described earlier. And we also support vector search in Capella and the self-managed server. And that enables that similarity and semantic search for better response precision for apps. And you can use SQL, right, which allows for predicates and joins and aggregations, ranges, and the like. And that makes searches even more precise and accurate. And then on the embedded database side, the bottom of this diagram, Couchbase Lite gets to join in the fun, right? It supports AI as well. It has a feature called the Predictive Query API, which can be used to call trained mobile ML models at the edge using app data stored locally in Couchbase Lite. And that makes the experience fast, contextual, and always available with no dependency on the internet. And Couchbase Lite also supports vector search. We were the first in the market to offer vector search on device. And that brings all of the vector search benefits that I just mentioned, but to the edge, right? Making searches super fast, even without internet. So the ability to power vector search on device and be able to support this edge architecture is a unique differentiator for Couchbase Mobile. A lot of other database vendors only offer vector search in the cloud where it's dependent on the internet. And when we apply the AI capabilities available in Couchbase to this edge computing architecture, we see that Couchbase syncs and processes data as well as AI in the cloud, at the edge, and on device. And that brings the scale to handle the massive amounts of data required for AI, as well as edge capabilities for the immediacy to make it effective, even when completely offline. So Shivay, I've been talking long enough. I think we want to get now to the star of the show, your demonstration. So I'm going to turn it over to Shivay, who's going to show us an example of an offline first adaptive application in action.
Absolutely. And thank you so much, Mark, for that wonderful demo of the Capella IQ. That just kind of showcases how AI really augments whatever you do. And I think even at Couchbase, we are just leveraging this wild ride that all of us are part of, and just leveraging that same AI capabilities, but for helping solve customer issues and real world problems that can really get empowered by leveraging capabilities like the vector search or that retrieval augmented generation that you showcased. So the demonstration that I'm going to be talking about today is the base quiz. So it's a mobile trivia game built with the help of Couchbase Lite. I chose a Couchbase Lite because it has an incredible amount of potential as an application for being able to run your offline database on device, whether it's a mobile device or even a low powered edge device as well. And in this particular demo, what we are leveraging is also the vector search. So as we mentioned, that vector search is not only accessible on the cloud, but can also actually run completely offline first inside of Couchbase Lite as well. So if you don't have access to any internet, you can very easily manage all of that with the help of Couchbase Lite as well. Now, let me also go ahead and start to share my screen to kind of walk over not just the demonstration itself, but also talk about the key architecture that we are going to be leveraging for this particular demo. So as I mentioned, that some of the biggest capabilities of why would you want to actually run vector search in the first place with Couchbase Mobile is that a lot of times you might want to do that semantic search in a complete offline manner, right? And that actually helps you to also lower down the cost because of the fact that all of that processing is actually happening completely offline. So you are reducing the latency and the query as well, because you're not actually sending all those queries to a remote server. And that way, if you're also dealing with a lot of highly private data, you can actually do that completely offline and not have to worry about sending your data. And we're actually seeing this advent with a lot of the popular mobile devices that are actually getting launched these days, with Apple, with the Google Tensor chips, capable of being able to run these embeddings and run a lot of the AI capability on device itself. So that really augments well with that offline database capability offered by the Couchbase Lite. And so that is why for this specific demo, I have basically gone ahead and built an app with the help of Kotlin, which we are calling as Base Quiz. And just to kind of, before I actually show you the demo, I just want to also talk about the architecture of what is basically happening. So in our mobile application, or in this case, in the quiz app, the idea is to generate a dynamic quiz based on certain preferences set by a person. So for instance, if you want to, let's say, take part in a quiz for food, right, related to food items. So you could, in theory, just upload an image of a food product, and using the vector search, Couch's Lite will be able to determine that yes, you have uploaded an image of a food item, and it will on the fly generate a new quiz based on food. So showing the capability of being able to generate personalized feed, or in this case, personalized products that you can see inside of the application. So what I've basically gone ahead and done is I took a bunch of images dataset that I collected from Kaggle, and here's like an example of how I did that. So here I have like a Kaggle notebook where I have basically taken a bunch of Indian monuments, and I took all of these particular monument images. I downloaded that data set, and then what I did was I basically ran it through an embedding model. So this embedding model is an AI model that will take an input image and then translate that into an n-dimensional image vector, which, as we mentioned earlier, is representing the semantic meaning of the features that are there as part of that particular image. So I ran all of these input images through this embedding model. Now, this embedding model is something that you can use, that's an online model. So in this case, I have basically two separate examples where I have generated these embeddings with either a really popular AI model, which is known as the clip model, which is basically a vision transformer. So here is an example of using the clip model. Or you can also actually use an offline first model, like something like an AlexNet, which is an open source model that and you can leverage. So the capabilities are immense. You can use a cloud version model to generate these embeddings, or you can also use an open source, memory first model as well, which you can run completely offline on your device. And the example in the today's demo that I will show is using AlexNet, which is an open source model that will help me to take all these images and then generate an n-dimensional embedding. And then what I do is that all of these embeddings that I'm now generating, I'm storing them of Couchbase Lite. So while I launch my application for the first time, all of these embeddings get stored inside of Couchbase. And now when it comes to the actual search experience, I take a new image, again generate the input image embeddings with the help of the embedding model. And now I use the search service, which is essentially the vector search capability offered inside of Couchbase Lite and inside of like Couchbase as well. And I find the most relevant or the nearest vectors with the help of algorithms like the KNN or the ANN, which allow you to find the most closest vectors matching your input vector, which of course in real life showcase that, yeah, these are the set of images that have the nearest features in terms of the image that you have just uploaded. So you basically end up generating a list of similarly ranked media items, and you can show those as results. So enough of the architecture, let's jump right into the actual demo itself. So here I have my Android Studio running right now, and I'll also quickly give an overview of how everything is kind of working. So what you'll see is this is my app, which is known as Base Quiz with a nice Couchbase logo. And here at the starting of the screen, I can enter in a name. So in this case, I can enter in my own name. Let's say I call it Shivay LinkedIn demo because we are doing a LinkedIn live. So let's name myself as a username, right? Now, what the expectation of the app is that you can upload any image that you want. Just to kind of give a background, I basically chose three different kind of images. So in my input image JSON, which is showing all these embeddings. So I took a bunch of images as I showed you in the example over here, where I took an image data set of Indian monuments. So similarly, I took another set of images. One was Indian food and then flowers. So the idea is that I originally trained my entire set of images and generated the embeddings based on these three different categories. So this image underscore embeddings.json is essentially containing the generated embeddings for all of those different items. And the only thing that I went ahead and did was I also added additional categories, because these categories will just help me to identify the nearest embedding that I get from the vector search, and then I generate a quiz based on that particular category. So in this case, I have some images with the category of food with their with their embedding itself. And then if I scroll down, you can see there are certain ones with flowers as a category. And then finally we'll also see some with respect to the monuments. So what I do is that inside of my database manager Kotlin class, what I essentially do is that on the initial load of my database, I initialize all of the collections and my index. And then I also have this particular function which is importing all of that data from my JSON file and storing those embeddings inside of Couchbase Lite. So this is done on the first initial load of the actual database itself. Now, the most important part of the actual experience is the search part. That means that as soon as I will now upload an image, and here I will just use the category as my log just to kind of show you. So the idea is that as soon as now I select an image from my mobile, I can use any image, and then I basically upload that particular image. What will happen is that my app will first call an API. So in this case, it's a post request to first generate the actual embeddings itself. And for that, I have this Python script that will take that input image and it will help us to generate an n-dimensional vector. And I'm running a Flask API or a Flask app, which is running this Python code to generate that embedding. And it will return the actual JSON embedding inside of a JSON over here, which I then return back to my Android app. So for instance, like for example, when I click on upload an image, I select an image of, like, let's say, in this case, I upload an image of fries. So you can see that it basically generates a log over here with that input embedding. Now, what I do is that I essentially pass this input embedding for the new image that I'm sharing inside of my SQL++ query. So here you can see that what I'm doing is I'm asking it to return the ID, the name, and image vectors of all of those nearest matches based on the input embedding or based on the input image that I have sent. So using the vector search, which is like the vector match, it will search the actual Couchbase Lite database to find the images with the vectors that are nearest to the image vectors that I have just uploaded, right? And using the KNN algorithm, and we have like some really nice blog post on our Couchbase blog, which kind of dive deeper into the engineering side of things of how the vector search actually works behind the scenes. So I'm finding the nearest vectors that have the nearest semantic similarity based on the image that I've just uploaded. And over here, what you can see as a log, right? So this is one of the logs based on the results that I fetch from Couchbase using the vector search. So in this case, I have this image object where you can see that I have the unique ID, the name, which I'm basically asking, I'm requesting Couchbase to basically return to me. And here I have the embeddings of the nearest matches. So in this case, you can see that the first nearest match was that of with the category of food. That means since I uploaded an image of food, you can see that with the Couchbase vector search, I'm able to find those. And then the next one that you might see as well is again with the category of food. And the third one is category monuments. But since now, as if you're not aware with vector search or with the KNN, you find the most nearest vectors, and then whatever is having the mode of the data. That means whatever data that is the most prevalent. In this case, I got two results with the category of food, and like we got three results because I've put the value of how many number of nearest neighbors do I actually want. So you can always tweak this according to, like, let's say if you want 5 or 7, that's something that you can optimize in your code. And in this case, since the majority of the nearest vectors were from the category of food, so it basically determined that the end result is food. And now when I generate a quiz, it will basically generate a dynamic quiz based on food. So here, as part of my application, I have, of course, like defined a specific collection for the score that you will have. So let's take part in this live quiz. So kimchi, I think, is fermented cabbage, and then we can further take part. So I think this noodle dish is mul vegan, and then we have some questions related to Indian. So gulab jamun is made up of milk solids. And then I think like this should be shai paneer, which is like a really nice cottage cheese. And then finally, queen of spices is actually saffron. So as I complete this quiz, as you can see that I scored 5 out of 5. That's amazing. And then I can finish this quiz, and I can perhaps take part in another quiz just to kind of show you, how that would work. So I'll just take another username right now, and perhaps let's upload an image of something else. Perhaps let's take an image of this monument. As you can see that it was able to correctly determine that this is a monument with the help of the vector search. And when I generate now the quiz, it generates a quiz based on monuments. So that kind of gives you an idea that what I just basically did was I took a bunch of input images, I generated the embeddings, and I stored them inside of Couchbase. And now I'm basically leveraging an AI model which is completely offline. You can run this on device as well. There are a number of ways in which, if you wanted to actually generate these input embeddings directly on device, there are tons of tooling. Apple embeddings allow you to generate these embeddings offline. You can use a TensorFlow Lite or MediaPipe and run them on your Android device as well to generate these embeddings. Of course, like I'm running this on a local server, which where I'm just passing on these images. But you could technically also just store the actual images themselves on Couchbase Lite and run a predictive querying system where you can leverage the APIs provided by Couchbase Lite and then generate the embeddings on the fly. Because this was a POC just to kind of show you how I first of all generated the embeddings in the first place, and then I ran them inside of my code. Now, of course, this is all great, right? I'm able to store, I'm able to generate these embeddings locally. But of course, we are celebrating the National Cloud Day, right? And that's where another really important aspect of the vector search, or not really vector search necessarily, but of the Couchbase Lite is the easy way to actually sync your data with the cloud with the help of the sync gateway. So what that allows you to do is that in case where you don't have access to the internet, so you're not able to connect to the main database cluster. In this case, it could be a Capella cluster or a Couchbase server cluster that's being deployed remotely on any cloud provider, or with the help of Capella, which is the managed cloud service solution. You could still do all these things that you're doing, right? So for example, if I'm now just quickly taking part in this next quiz, I am basically storing all of this data right now locally in my system. And I can see the leaderboard where I have stored the results over here. And now the idea is that I want to sync this very easily back to my main database cluster. I can do that very easily with the help of something known as the sync gateway, or inside of Capella, which is basically known as the app services. So I will just quickly go ahead and log in into my account, into my Capella account. And I have this demo that's running right now. And Here, basically, I have this default scope bucket, at the bucket with the scope as default, and all of these particular examples that you see, right, which you see right now, these results are coming in from the data that is basically getting generated, and this is actually completely linked to the local app that I'm running with the help of the replicator service. And I'm running the app service. So basically, the app service is a tooling that's provided by Couchbase Capella, which allows you to essentially just connect your Capella with any local Couchbase mobile or Couchbase Lite application that you're running. And it uses a push-pull mechanism to always ensure that your data that's there locally is always in sync with the data. And like, let's say in cases where you don't have internet access, and once you later get access back to the internet, it will always sync your cloud cluster database with your local database as well. So just as an example, here I have basically implemented that same replicator logic with using the app services. And for instance, like I'll have certain doc IDs, which I have, I took part. I think like the latest one was with the query LinkedIn. So for instance, now if I specifically search for this particular doc ID, I should be able to see that I think like I can increase the limit to 100. So let's increase this limit to 100 now, and then use this one over here. So it should find, and like I had some other examples as well, which we can leverage. So I have a bunch of different doc IDs, and the idea again is that what we are basically, as you can see, right, that we see that this score document was successfully stored. And I guess like I can quickly do a demonstration again, just to kind of show this live. Demo 2, and I'll just quickly upload an image of, like, let's say another, in this case, like this is the rice image, and I'll generate the quiz. I will quickly just take part, and hopefully we should see like a new document ID getting generated once I final or like finish participating. So here, as you can see, that this particular doc ID now should be also accessible within the set of documents that I have over here within. So if I perhaps, like, let me just try to search for the document, hopefully, yeah. So as you can see that it came up automatically, it synced automatically to my cloud database, because all of the things that are happening locally in my database, in my Couchbase Lite database, are in sync with in my Capella as well. So that's a quick demonstration of the capability of the vector search happening all the way in the actual cloud as well as in your mobile, and how you can very easily use services like the app service and the gateway sync to sync between the cloud and local, so that if there are times when you might not have access to your cloud cluster, you can still have a fully managed database locally running, and then you can very easily sync without having to do any manual effort at all. So that is a quick demonstration of the vector search capability with the replication.
Awesome. Thank you so much, Shivay. That was really great, especially where you were offline completely, and then you were able to synchronize up to the cloud. And I understand that that actually also works in reverse, right? You can
Yes.
sync from the cloud down to a massive number of mobile devices. So again, give it a try. There's a Capella free trial, and we'll show you where to go at the end of this presentation. But we want to leave a little bit of time for questions. So just really to sort of cover off on scalability, performance, and low TCO, a couple of customer case studies. Tech Validate is a platform where customers submit their own feedback for case studies. And so it's about as real world as feedback can get. And what's noteworthy is more than half of the customers surveyed said they had greater than 50% reduction in TCO with Couchbase. Total cost of ownership goes down dramatically thanks to its performance, scale, multi-purpose capabilities, and flexible deployment models. And what really backs up those reviews are benchmark tests against other cloud databases in the market, which show that Couchbase Capella outperforms the competition across the board, in terms of workload costs based on operations per second in each test. And in every workload, we see a cost difference where the other guys are nearly double. So the source benchmark studies are available at couchbase.com on our website. Be sure to check them out. They were conducted by an independent third party called Altoros. Very eye-opening results. And I've been mentioning all day, we love to brag about the fact that LinkedIn, who is hosting today's event, in fact, we're streaming through that platform, are one of our biggest marquee customers. They outgrew Oracle and eventually chose Couchbase over MongoDB and Redis to be the caching solution for its source of truth data store. So thanks to its ease of use and extremely low latency, Couchbase supports over 50 use cases company-wide, not just the apps that we might use day in and day out, but 50 apps across their ecosystem. And Couchbase is used for all in-memory storage in the data center. We power 10 plus million queries per second. Just think about the worldwide use of LinkedIn. And on performance at scale, they average less than a 4 millisecond latency for over 2.5 billion items. Just tremendous performance and results at LinkedIn. Swarm Engineering provides a SaaS platform for the agriculture industry. And this is to optimize their supply chains using AI. So their customers actually save millions of dollars with the solution by minimizing wasteful processes and reducing environmental impact. And the interface is an AI-powered digital assistant powered by Couchbase's key value store. And thanks to the solution, their customers see, they can actually plan out their supply chain operations 400% faster, right? And see an average ROI, return on investment, between 3 and 10x. So really great results there. And lastly, Nexon. This is a giant game studio. They needed to modernize their infrastructure and make it easy to deploy to new markets quickly anywhere around the world. And while at the same time, make development easier and more efficient for their developers. And of course, Couchbase Capella was able to meet all of these requirements. Our adherence to relational constructs and SQL meant the developers adopted it really quickly, and that accelerated development. And the JSON document model made it easy to evolve user profiles on the fly for painless updates. And the speed and scale was more than able to meet the demands of gamers who expect immediate gameplay at all times, anywhere they happen to go. And Nexon was able to roll out this game, Blue Archive is what it's called, as a big hit. And they can now also expand to new markets in just minutes versus days and increase that global reach. So with that, we want to thank everybody for being here. We've got a few minutes left for some questions. I think one came in for Shivay already. But really, the summary here is that Couchbase is uniquely poised to power the future of these AI-driven adaptive applications by providing that hyper-personalized experience that's in context, it's innovative, highly performant and responsive, and can work anywhere around the globe with or without internet connectivity.
And yeah, just to kind of answer that question that we got, I think we can probably take that up. So the question was, can you explain better how do you train the model? So in this case, there are really just two main approaches, right? You can use a really state-of-the-art model like the CLIP model that has already been trained over millions of different textual image-based data. So it kind of depends, right? And sometimes what you might want to do is that if you have a very specific use case, you can always fine-tune these models. And fine-tuning involves using a new subset of data and then retweaking certain model params or the model parameters that help you to make that model more optimized for your own use case. So at least for that demo that you just saw, I took the state-of-the-art CLIP model or the AlexNet model and just used that to generate the embeddings. Now, given the bigger the size of model, the more it has been trained on, it will give you more accurate representation of the actual image data, or in case you were using a text-based data. So it always depends on how much amount of optimization do you need. And then there are always ways of just using fine-tuning to tweak the way that the model will react to your own data if you have very specific set of data set. So it all depends. It's always situational and use case driven on whether you want to apply just using a model straight as it is, or you might want to apply fine tuning.
Yeah,
Great.
well said, Shivay and Mark. Thank you guys so much. We need to wrap things up, but I did want to call a couple things to your attention. Obviously, the Capella free trial, if you want to try out Capella for yourself. I also put a link to the free trial sign up in the chat. So please do take advantage of that. Secondly, yeah, join us on Discord. This is our community. So a lot of questions, developers in there talking about, their projects and what they're working on. So great community if you'd like to join us on Discord. Another call out, we actually did do a really good data modeling webcast with Matthew Groves a few months ago. So I went ahead and put that into the chat as well. Hopefully you can view that on demand, learn a little bit more about data modeling. And the final call out is we are doing a series of test drives. So if you're already looking at Capella or if you haven't downloaded it yet, but you would like to try it out, come to one of our test drives. They're live, so you get to work with an SE and get all of your questions answered and hopefully get up and running in 90 minutes. So I put all of those links into the chat. Of course, if you'd like to reach out to me or Mark or Shivay also, we can help you navigate any of the questions that you might have. So thanks again, everybody, for joining us. Happy National Cloud Database, and we hope to see you all at an event very soon. Take care.
Thanks, everyone. Thanks, Shivay. Thanks, Suzanne.